shows energy analysis in Revit based on the notes which are available on the VLE. And we start with creating a new file, but from the architectural template, not structural. And the reason for that is that the elements are already preloaded into that template, so it's easier. We don't have to load families and so on. So creating a new file, and then the first thing, we can save that file and save as a project and save it in the downloads and call it energy analysis. Energy analysis. I'll call it energy analysis 2. Now we need to define in the Manage tab project units first. So for the length we'll use meters, and for this is all fine. For the currency, I will change the currency to pounds and click OK, and the rest is fine. We don't need to make any changes there. Looking at the energy, energy is in joules. We can change it to kilowatt hours, which is a more common unit. And then the coefficient of heat transfer stays the same, and the rest of the units stay all the same. So then we click OK. And the first, apart from changing units, the first task is to specify the geographic location. And if we want our project to be where London South Bank University is, that will be the postcode SE10AA. And we can search for this and accept it. And once we've found the location, several weather stations are shown nearby. The nearest one is very near the university, so I can choose this one and accept daylight saving time. So that will specify where this project is located. Next, so this was the first step. Next step is to create the model of a building, and I will start by creating two levels, level 0, 1 and 2. So in the elevation, any elevation view, and just click on architecture level with the offset of 4 meters. Not 4,000, 4 meters, because I changed the units to meters. And I will stretch a bit the level lines and escape. So these are the levels, and the next part is to create an external wall for a 30 by 20 meter building. So going into the level 0 plan view, we choose the architectural wall tool, and we want the external wall 215 brickwork wall. Now for this wall we can check by edit type, we can check its structure. So it has just basic brick with no insulation. And here we see the R value and the thermal mass of this wall. If we go here into the brick common, we can also see the thermal thermal properties of individual layers. So for example, specific heat, thermal conductivity, density, and so on. So this means that the thermal properties of our element wall, when we place it, are predefined and given in the library of Revit materials. And now we can place the wall by, easiest would be just with a rectangle, and before I select it, the height of the wall is to level 2, and the location, we can accept wall center line to be at that position, and we have the horizontal, in the horizontal direction we have 30, and in vertical 20 meters. So I could just draw approximately, and then it will, if we want the internal dimension to be 20 meters, and then in the other direction it's 30. So this, we can see it's the inside dimension, which is fine for our purpose. We don't need to do anything else. And I will just drag this outside, and the same for the east. Yeah. So we can see our wall now in the, let's check the north, that's our wall. And I'll just, to tidy it a bit, move this outside. And now we also, so this basic wall is a north, east, and west elevation, and curtain wall exterior glazing for the south elevation. So best is now to view this in 3D view. Make sure our object is rotated, so south elevation is this one, and so we can select the south wall and just change the type to curtain wall exterior glazing. That's it. We don't need to change any other properties of this wall. Now we can create the floors starting from level 0. At level 0, the floor is ground 655, etc. If I look at this this type, here I can see it has several layers, and in the preview we can see all those various layers of the ground slab, ground floor, and we have also its total R value and thermal mass shown. And again, if we go into any of these elements, we will get its thermal properties. For example, going into this rigid insulation, we can see here the thermal property, the conductivity, etc., specific heat, and so on. So, as mentioned in the second handout, these conductivity properties are used to calculate the overall R value or U value of the multi-layered floor. So now that is our floor, and we just need to place it. The easiest way will be just to pick the walls that are surrounding that floor and accept. Cannot intersect. Okay, sometimes you have this kind of error, so that's probably because of the difference in the walls. So I'll just click continue. Oops, I could have. So I can see here that this is not connected. So if I press escape or modify, okay, now I don't have to press escape, just need to move this, and then I think I have the same problem on this side. No, I don't. Okay, so let's try now. Yeah, the floor is now created. And now I can actually copy this floor to the level 1, or I can just create it at level 1 from scratch. I can create it at level 1, escape, and then level 1. So at level 1 the floor is now timber 22 CBD 225 joist. CBD stands for chipboard, and that's all we need to do. Pick walls again. Will it work now? No. Continue, and again, for some reason this does not. Press escape, select the line, and just connect it and accept. The floor overlaps. Would you like to join geometry? It doesn't overlap, does it? No. Where does it overlap? It doesn't overlap. Okay, not a huge issue. And then level 2. Level 2 is the roof. So for some reason the walls are not showing at the level 2, although they are going all the way up to level 2. So I can change the underlay to level 1. Level 1. Okay, so it will show me the walls. And now I can do the roof. Yes, so I choose the roof, not define slope, and then choose the outside corner, and here also outside corner, and accept. So this is just a plain flat roof on the level 2, and now I can look at the building. So these are the walls, outside walls, and now I need to place some windows as well on the elevation. So if I want to place windows in the plan view, so in level 0, I can just use the window tool. This is the standard window, and this is the on this wall, I can just put a few windows. I can move them later on, so 2, 3, and then another 3, like this. And then in the same way you would need windows on the other side, so I can just use mirror tool, which is mirror, mirror, mirror. Okay, so if I need to select the elements, I'll select these ones and then press enter. And then for the mirror here, and just a vertical line, doesn't have to go all the way. And now I can use the mirror, and then I'll select the windows, press escape, and then select the line. Oh, it tells you to escape. So this tool now, these are already selected. Okay, eventually I got it right, and now I can delete the line. And now just on the north elevation, I have these 4 windows. So I'll just place these 4 windows somewhere on the north elevation I can move them later, but I think they're on this side. Escape, and now escape, and now I can copy these windows minus the wall, copy, and then paste a line to level 1. Let's see. So now if I look in the 3D view, I have created these windows. I don't care much about their height or positioning. Let's just check also the north elevation. So okay, this window is not there, and if I look at the east, also there are 2 windows less on the top floor. So this one and this one for some reason is not there, and the same on the west. So this one and this one are not there. Okay, so now we have these windows placed, and the last bit is now to place the internal walls, and that we first do in level 0. So the internal wall is just the only internal wall that is in this list, and we'll just place one approximately here, and then have one starting here and going up to this point. And I didn't press change, so I'm doing them individually, and then I'm doing one here as well, and here as well. Okay, and now on level 1, should have the floor in the same place as in level 2, but that's easy to do because we can see them. So we do the wall architectural, and then the first wall is just on top of that wall, and then we have the wall going up to here, and then one wall here, and something like this. And in this escape, and in this view now I can hide the underlay to none. So just to make sure all these walls are from level 1 up to level 2, yes, because I haven't really looked when I placed them. And on the level 0 the walls are up to level 1. Okay, I didn't check. So now we have the walls. We need to add spaces. In the Analyze tab, we can click on the space, and it says load the tag, and we can load the tag from annotations, mechanical annotations, mechanical space tag. Make sure tag on placement is selected, and we can place spaces automatically. So we have already created these 5 spaces, and they are numbered automatically. We just need to later on rename them. And the same level 1 space, place spaces automatically, close, and here are the spaces on level 2. So this is quite quick. And then in level 0 I need to rename these spaces as the handout shows. So this first space is Office 1. Then we have here Office 2, Conference Room 1, toilets, and Lobby 1. Then on the first floor we have the numbering will be slightly different, but that's not a big problem. We have Office 3, Toilets 2, Conference Room 2, and Conference Room 3. And then the last one is Lobby 2. So our spaces are named. If we select one of the spaces, we can we can also see its name and number here in here. So spaces are just architectural, and I'll click on the zone, select the first one and finish. Then zone number 2, finish. Zone number 3, finish. Zone number 4, okay, and then number 5. Escape. Zone number 5 and finish. So then I'll go to the level 1 and create zone number 6, finish. Zone number 7, zone, okay, has it done it or not? I don't know now. Zone number 8, zone number 9, and lastly zone number 10. Zone number 7, edit zone, remove space. So here is escape, zone, this one, and finish. Okay, so now we should have the 10 zones, which shows here, and now we need to specify area and volume settings. So in the architecture tab, room and area panel drop, we need to choose under volume computations, area and volume computations, areas and volumes. Areas and volumes. Okay. And now I can go now it is. So we have area, level, perimeter, and volume. I'll just move level 1 up and click OK. So I needed to include also to add the space name. Or number, or both. And I'll push these up. Okay, so we have all the spaces and their properties. Okay, space schedule, that's fine. Now with this we have finished entering the data, and we can just create the energy model, and that will be just check everything. So if we check our energy settings, which are in the analyze and here energy settings, so we are going to use the conceptual masses and building elements. We don't have any conceptual masses, so we can just change to use building elements, it doesn't matter. And here are some of the options, and here office building, building operating schedule, we can change from 12 hours a day, 5 days a week facility, and then export category, rooms or spaces, I don't think it matters. And this is just something for the mass if you're using conceptual types. And here detailed elements, tick, and click OK, and OK. And now we can create the energy model. And now that this model has been created, we can click on Generate, use existing energy model, and then click OK. So now we need to go to the Green Building Studio. It will take a bit of time to process this calculation, energy analysis, and once it has been done in the Green Building Studio, there will be the results. So we're sending our model to the cloud to to be processed. So now I have my file here, but it hasn't been run yet, Revit, and I can go to Analyze tab and look at reports and schedules, heating and cooling loads. So this is showing, this can calculate heating and cooling loads. For this project. Total area, volume, and quite a lot from this information, which I will talk about in the next video. Just going back to the Green Building Studio. I think I had to run it. Okay, so it's done, and the units are unfortunately dollars. I don't know how to change it. The default utility rates can be changed, so cost per kilowatt hour and fuel cost. And then so all these lower ones we don't need. these are alternate, so with some modifications to the applied to the building. So energy analysis will give us the energy results. So annual energy cost, annual CO2 emissions, and annual energy, and then life cycle energy, so the energy in fuel use for the whole life cycle. Then we have some charts. The charts show how the electricity is used for heating, ventilation, air conditioning, and lights. What would be other? I'm not sure. Okay, so fans, pumps, exterior load, miscellaneous equipment, and so on. Here you have space and hot water. We have